data engineering with Jupyter MCP project. So we'll be building an interactive Jupyter notebook that queries databases and lets you visualize data using the cursor, or using cursor to work with the Jupyter Notebooks MCP. So the difficulty of this is written as easy. Certainly a beginner-friendly project. I definitely recommend doing both the PostgreSQL MCP project, which is part 1 of the series, as well as the DBT MCP project, which is part 2, the previous part, and we're actually going to be using one of the bits from that project in the second mission. So that'll be super cool. Sounds good. Let's go. Yeah, let's go. This should take about 60 minutes if you're doing this by. Realistically, we'll want to work through this on live stream. But yeah, should be all good. So key concepts is Jupyter Notebooks, PostgreSQL, Matplotlib. I'll touch on what these mean in a second. But Jupyter Notebooks, well, way of like taking an environment for a sort of a live environment for running code, document, visualizing it, sort of almost tell a story what your code's actually executing and going and doing. Really good for documenting what you're doing, come back to it. PostgreSQL, that's a database framework, relational database framework, open source one that we've been using this series so far, super popular. Definitely recommend going into this project if you haven't already. And doing it, executing it. We explain pretty in depth how it works there. And Matplotlib is a Python library, Python package for creating visualizations of data. So we're going to be using that to do that from our database. So those are the 3 topics. Your key concepts. A 30-second summary. Imagine you have customer data in a database like we do. We want to explore it, find patterns, test ideas, visualize trends. We could export CSVs, comma-separated value files, switch between SQL clients, copy results in spreadsheets, or we could work like data engineers do. So they use Jupyter Notebooks to explore databases interactively, write a query, see results. We could transform that data with Python to visualize it with charts. And we can document as we go, creating a sort of almost like a report. So that's going to be all in one place and shareable with a team, or friends or on LinkedIn or anything. Totally cool too. So you'll build this workflow through Cursor's chat, connecting Jupyter Notebooks directly to your database, running queries and creating visualizations without jumping tools. So that's going to be all in one place and shareable with a team, or friends or on LinkedIn or anything. Totally cool too. Very good. So you'll build this workflow through Cursor's chat. So what you'll build in this project, you'll use Jupyter Notebooks to explore customer data from the PostgreSQL database we're building. And if you haven't built that already, that's completely fine. I'm going to catch us up to speed on that. Do it again from scratch. We've got a quick catch up tab to do that, which would be real cool. And then, yeah, once we've done that, we can create visualizations using Python through the Matplotlib library. So why Jupyter Notebooks? Code is read more often than it's written. So a few weeks from now, you might ask, why do I join these tables? Why do I filter for a certain value? Once we've done that, we can comments help and code comments. But using Python, data analysis needs context. This could be tables, charts, and explanations. So all 3 wound together will give you the best picture of what whoever, you or someone else, was really thinking when they designed it. Wrote the code initially. That could be yesterday, it could be in 6 months' time. Really. So all 3 wound together will give you the best. So Jupyter Notebooks mix code, visualizations, and documentation all into one place. This literate programming approach popularized by Nuff is essential for data work where your source shapes your decisions. Data teams use notebooks to explore databases, test ideas, and share findings with teammates. You don't need any prior knowledge for this. Of course, it's good if you do. This project teaches you how to use Jupyter Notebooks from scratch, how to connect them with databases, so we use the PostgreSQL we've already created, and how to create visualizations that reveal insights in your data. So we can also use the Ask feature here to check if this is right for us. You click on this, open it, and then check if the project's right for you. So how you build it? First, you create Jupyter Notebooks by hand, understand how they work. Then you'll use Cursor with Model Context Protocol to manage Jupyter Notebooks through conversation. So the architecture diagram here highlights how start with Cursor, then move to a pipeline. We won't be moving, but the information is going to be going from Cursor to the Jupyter MCP with a prompt to create or run or do an action on a cell. Jupyter Notebook cell is a block of code running in Jupyter Notebook. Which you can execute, and that's going to query the PostgreSQL database. That's going to return data to the Python function or the cell in Jupyter that's executing, and then that's going to display results back in Cursor. Cool. That's going to query the PostgreSQL database. That's going to return data to the Python function or the cell in Jupyter that's executing, and then that's going to display results back in Cursor. So by the end of this project, you'll have a working Jupyter Notebook connected to your database, Python code that fetches and analyzes customer data, and an interactive visualization showing customer distribution with Matplotlib. So by the end of the project, you'll have in this project, I'm going to your database, Python code that fetches and set up customer data, interactive visualization showing notebook customer distribution with Matplotlib. Python code to query in this project database. Jupyter Notebooks are environments. Both write code, Python code, document database. Jupyter Notebooks. I'll connect them to environments, my PostgreSQL database. I'll connect them to my Postgres. Cool. Database. So what are we doing in this project? In this project, I am going to set up Jupyter Notebook with Python code to query the database. Jupyter Notebooks are environments where you can both write code and document it. So that could be visualizing what we're going to do. Otherwise, could be writing text around it. So what are we doing in this project? I'll connect them with my PostgreSQL database. Set up Jupyter Notebook with Python. Sweet. Code to query the database. Jupyter Notebooks are environments where you can both write code and document it. So that could be visualizing what we're going to do. Otherwise, could be writing text around it. I'll connect them with my PostgreSQL database. So we'll do the quiz at the end, but if you're up for a challenge, you can totally do the quiz now too. And we're going to be going through the step-by-step guidance mode. That's the one that I'm going to walk through in this live stream today, but definitely check out some guidance. Might be right if you feel up for a challenge. And we're going to be going through the step-by-step guidance mode. Cool. So this is the video. Yeah. Cool. So step one's connecting cursor to Jupyter. So it's time to connect cursor to the Jupyter notebook. We'll set up the Jupyter MCP server through cursor. So you can write Python code, query a database, see results, all through conversation. The step, get ready to add the Jupyter MCP server configuration to cursor, verify the MCP connection is actually active. You can write Python code, query a database, see results, all through conversation. So in this step, I'm setting up Jupyter MCP, which is context is actually active for. In this step, I'm setting up Jupyter MCP, which notebooks. Jupyter MCP will let me interact with notebooks that could be creating or running cells via the cursor chat. Interact with notebooks that could be creating or running cells. Cool. So what are we doing in this step? In this step, I'm setting up Jupyter MCP, which is a model context protocol for Jupyter Notebooks. The Jupyter MCP will let me interact with Jupyter Notebooks, which is creating or running cells. Creating anything, really. Running cells, so executing code via the cursor chat. Check your current MCP setup. So before we add Jupyter, let's see what MCP servers you already have configured. So we're going to go into cursor now, to the IDE. Second to open. Check your current MCP setup. So before we add Jupyter, let's see what MCP servers you already have configured. So we're going to go into cursor now, to the IDE. Second to open. So what I'm going to do is open this up on the left-hand side. It's running on the right, so you guys can see what I'm doing. Cursor following along. So what I'm going to do is open this up on the left-hand side. It's running on the right, so you guys can see what I'm doing. All right, so we're going to go into settings here. We're going to go into MCP. So in this case, I don't see any Docker or Postgres, so you would if you either set it up just for your own personal use or done a previous project, which is the PostgreSQL project. So in this case, I don't see any. Cool, so no worries. Here's the fast track setup, takes about 15 minutes. You can set it up just for your own personal use. You set up with Docker, Postgres, and Jupyter. So you set up Docker Desktop, UV Package Manager, UP servers, and demo data. Cool. So I'm going to do this quickly as well. Just open up a terminal, Windows, so or PowerShell. Yes. Cool. So I'm going to do this quickly as well. PowerShell here. Terminal, Windows, so we can send the command. Check we have Docker installed. Cool. Done. There's steps here for setting it up and installing it, both Windows and Mac. Now we're just going to check if UV is installed, Package Manager. Check we have Docker installed. So we'll copy that command. Paste it into here. Cool, good to go. Now we're just going to check. So I see a version number, so we now open Cursor and download it if you don't have it. We also have an entire project on Cursor. So cool, good to go. Yeah, definitely check that out if you want to learn how to do that. So I'm going to minimize this now. So yeah, definitely check that out. Click Open Project. Hit to my desktop. So I'm going to create a new folder. MCP data series. Select this folder and it should open it up. Cursor, open project. Hit to my desktop. Nice. Okay. So we can open the terminal and run these commands one by one. Cool. So that initialized a UV environment. You can see here it's already a member of one. That's because I've run this before on my desktop, and that's just stating that it understands the relationship between the pre-existing environment and this one. Completely fine, harmless. You can see here it's good to understand, and it no need to do anything. That's an issue. All of that comes up. Sorry. And the second command is going to set up Postgres with Docker. So we see here, nothing running, no containers. And the second command is going to set up. Cool. So let's give a container ID. Very good. See here, database is up and running inside of PostgreSQL. Database is up and running inside Docker, which is great. Cool. And yeah, definitely wait a little bit of time before doing anything now, because it can take a little bit of time, maybe 10 seconds or so, to actually open the database. And yeah, definitely wait a little bit of time before. I'm just going to use the /clear command, or just not /clear, just clear, to clear the terminal here so you guys can see actually open the command of the database. So I'm going to select the Windows tab now, wait a little bit of time for PostgreSQL database to start up, and then I'm just going to copy this or these commands here, which is going to download the demo data file and then push it into our PostgreSQL database. Shouldn't take too long at all. And then I'm just going to copy this or these commands here, which is going to download the demo data file. Nice. Okay, so it's created the schema, tables, and inserted stuff. It's great. This is the file it downloaded. And it's put everything into our Docker PostgreSQL database. Nice. Okay, so it's created the schema, tables. So now we're going to go and set up Docker and Postgres, and then go out to Jupyter, the MCPs for them. Put everything into our, because I'm following the route that didn't have anything set up. There's definitely a tab and have these set up, so just click on that if that's the case. So now we're going to go and set up Docker and Postgres, and then go out to Jupyter, the MCPs for them. Cool. So we'll click the settings icon here. That didn't have anything set up. There's definitely a tab and have these set up, so click on that if that's the case. Cool. So the settings icon here, and then find MCP. You can see we've got nothing here at the moment. It's all good. And so we're just going to select Windows here. If you're on Mac, go for that. There are slight differences in this Docker host URL. Sorry. You can see we've got nothing here at the moment. It's all good. And so we're just going to select Windows. We'll go with this for now. So we'll just drop that in there. So just copy and paste that over what I had. Click Control S, save. Close that file. So what does this configuration include? It includes Docker, lets Cursor control Docker containers that we just had, and Postgres, so that lets Cursor query our PostgreSQL database. use shortly for Jupyter. So we're all set. You now have the same setup as someone who completed the PostgreSQL MCP project, the first project in the series. We just missed out on a few of the, the rest, like actually doing stuff with these tools. Cool. So what about the DBT MCP project? So the DBT MCP project introduces data build tool for transforming data. It's not required for the Jupyter project. You could skip it. We'll come back to it later. Definitely recommend it though. It's got some great learnings in it. We're actually using the DBT MCP for the last secret mission of this project. Getting really cool. So now we're caught up, so now we're going to jump back into setting up the Jupyter. So add Jupyter MCP configuration. Great, good job. Now let's add Jupyter to your MCP configuration. Since you already have Docker and Postgres configured, you just need to add Jupyter. In the MCP settings menu, you should see still be open. New MCP server, so open MCP.json file. Close settings, go back. And if you have any other ones installed, doesn't have to be from this series or anything, you can keep them in there. We'll just be walking through these ones to totally build around them. So it looks like this, so that's cool. So this is the Jupyter MCP MCP.json file. Should be all good. So there's a note about this in a second, but it's important. So we're just going to add this here. It's important to add a comma. So this previous thing is a JSON file. So it's good to know. So what does this Jupyter configuration actually show or mean? The command uses UV to run the Jupyter MCP, its dependencies, args, and stores required packages. So MCP Jupyter for MCP integration, Jupyter Lab for the interface, Jupyter collaboration for sharing, IPY kernel for running Python code. And the end has just the for running this on. So that's all good. So we can save and close that. So check actually it's the same. So yeah, this looks like it all lines up. It's got Docker, PostgreSQL, Postgres, and Jupyter. And here's the they talked about adding the comma after the next or between whenever you're adding anything to this MCP or JSON or any JSON file. Cool. So we need to restart cursor now. So now that you've added Jupyter to your MCP.json, let's restart cursor so it picks up the new configuration. Save the file, Control S, Command S, put cursor, and then should be able to be up there. Cool. So we need to restart cursor now. So now that you've added Jupyter to your MCP.json, let's restart cursor so it picks up the configuration. So the reason this needs to happen is because MCP servers work on they start on boot up of the IDE. So yeah, that's why that's important for this. So we need to actually start with MCP servers. So now we can head over to this. We can either see if verify all three MCPs are connected. So that's Docker, PostgreSQL, and Jupyter. We've got 3 tabs here. All servers green. Jupyter shows red. All other servers are red. So these all have step-by-step explanations of how you can start to debug all this. If you've got all of them that aren't working, or just Jupyter when you added, in this case, you can see here, all 3 of the MCPs are actually green. So we can go down this path, but totally use the ask feature or follow the steps there. And there's also the community as well. Definitely recommend checking that out. Discord, it's got great people that can help with any sort of technical or non-technical problem you're having with walking through any of these projects. A great idea. We'll go through green because business working. Discord, it's got great people that can help with any sort of technical or non-technical problem you're having with. Nice work. Everything's configured. Let's move on to the next step. So, what about the DBT data build tool MCP? So if you see the DBT server, that's fine. Keep it there. We'll use it in the second mission. Won't interfere with this project. Correct. Nice work. Everything's configured. So upload a screenshot of your 3 MCP servers connected. What about the DBT? Take a screenshot of this. So if you see the DBT server, that's fine. Keep it there. We'll use it in the second mission. Won't interfere with this project. Correct. So upload a screenshot of your 3 MCP servers connected. Screenshot of this. Cool. How did you configure the Jupyter MCP? I added the Jupyter MCP to How did you configure the Jupyter MCP? Cursor's mcp.json file. After saving and restarting Cursor, I verified it was connected by checking the settings page for MCPs. Cursor's mcp.json file. Cursor's saving and restarting Cursor. Cursor's settings page. I verified MCPs by checking, making sure for MCPs. 3 MCPs. Cursors. It came as green page. Or it came as connected. So, how did you configure the Jupyter MCP server? I added the Jupyter MCP configuration to Cursor's mcp.json file. After saving and restarting Cursor, I verified it was connected by checking Cursor's settings page for MCPs, making sure all 3 MCPs were indicated as connected, as you can see here on the left-hand side. I verified it was connected by checking Cursor's settings page for MCPs, making sure all 3 MCPs were indicated as connected, as you can see here on the left-hand side. Cool. Very good. Very good.
We do daily maintenance and construction. We know who's on site. We know where they are.
All
we know
right.
what they're doing.
Now that's
Nice
how you run a
work.
field team. With Connect Team's employee management platform, you can get digital reports.
So step 2, build and run your first data notebook. Great work. Cursor is now connected to Jupyter. Time to create your first Jupyter notebook that mixes code, results, and explanations all in one place. Think of Jupyter Notebooks as living reports. You write Python queries, see results immediately, and add explanations of what you found, document your analysis journey. It isn't just running code, it's creating a story that others and future you can understand. Super cool. So in this step, get ready to create a notebook with code, explanations, and data. Query your PostgreSQL database from Python and see your analysis results in the browser. So in this step, you get ready to create a notebook with code, explanations, and data. Query your PostgreSQL get ready to create a notebook. Cool. So what are we doing in this step? In this step, I'm creating a Jupyter notebook. A notebook lets me mix code, explanations, data. This could be visualizations. Code, charts, tables, etc. Code. This could be visualization. Cool. So what are we doing in this step? In this step, I'm creating a Jupyter notebook. Notebook lets me mix explanations, code, explanations, and data. So data is visualization, which can be charts or tables, or other things too. So what are we doing in this step? In this step, I'm creating a Jupyter awesome notebook lets me mix explanations. So what are we doing in this step? Code, explanations, and data. Data is visualization lets me mix explanations, tables, or code, explanations, and so data is visualization. First, we'll create the demo.ipy notebook file, IPYNB. Let's create your first notebook, root directory of MCP data series, create a file demo.ipynb. So we'll leave that empty for now, come back to that. Notebook file, IPYNB. First we'll create the demo first notebook, root directory of MCP data series. So what does this extension mean? See that it's interactive Python notebook. The file that we can interact with. We're running our Jupyter server. We can work between either locally, or they're both locally, but either on web or in your IDE. So in cursor in this case. If you are familiar with how to create a file, you can right click on the file explorer on the left hand side, select the file. Either locally, interact on web or Jupyter server. Cool. So building your computable document. Nice. Your notebook file is created. Now let's build a computable document that mixes code, results, and explanations. So there's two types of cells, which we'll get into in a minute. Use it in a minute. Sorry, we're getting into now. The first type is a code cell. So a code cell is a place you can write and run Python code inside of Jupyter. It's a super useful thing to be able to do. It's really the main thing I think a lot of people think about when they think of Jupyter Notebooks, running code inside of it. And a markdown cell, which you can see here, is a cell that holds text in the markdown format. So you can create headers or checklists or all sorts of different formatting tricks in there, and it's really good. We'll use this and go into it to document what we're actually doing. Is a cell that holds text and a markdown cell. You see headers or checklists. Is a cell that holds all sorts of different formatting tricks in markdown format. It's really good. Headers. Use this and go into it. Checklists to document all sorts of different formatting. So let's build your first analysis document with 3 cells in the correct order. First, I'm going to add context with a markdown cell. So first, by documenting what you're about to do and why, let's build it is a really good option. So context comes first. So reading this top to bottom. So we're going to open the file, click the plus markdown button. Either one works. And we're going to add this explanation, which is a precursor to exactly what's going to be going in here below this in our documentation. So it says customer data exploration goal, connect to our PostgreSQL database and examine customer distribution. This notebook explores our e-commerce customer data to understand how many customers we have and what a typical customer record looks like. Cool. Why start with Markdown? A few weeks from now, you open this note and wonder what was I trying to find. Starting with Markdown documents your intent, context that raw code cannot convey. Cool. So install the database driver. We can select the code thing here. Read about what a database driver is. So we can click the plus code thing here. Underneath the markdown, and we can add this install. Cool. So what does the exclamation mark do in each command? The exclamation mark at the start tells Jupyter to run this as a shell command rather than Python code anytime the line starts with exclamation mark, executes in your system terminal. opposed to just Python code. Cool. And what is the binary tag there? So psycopg is a Python library that lets you lets your code run, connect to PostgreSQL, which is the database framework we're using. We set up the Docker at the beginning. The bracketed extra binary tells Pip to install a pre-built, ready-to-run package. Without binary, the install might take longer or fail if your computer is missing dev tools. Cool. Third, query your database, which is the code cell. This time it's actually Python. Let's add code that connects to your PostgreSQL database and queries customer data. We'll give you a template to fill it. So try filling the placeholder yourself, or check the hints below if you get stuck. So there's a hint tab here, but I might just read out what does this code do. What does this code do? Let's break down each part. So import, that's the database driver we were talking about. So it loads that driver library in. The connection tag opens a connection to your database using your credentials, and the credentials are so there's a host, port, the database name, the username, and a password. This is stuff we set up in the initial command we sent on earlier to create the database, and then we've got a creates a cursor object that lets you run SQL queries, and then runs an SQL query to get one customer record. So that's a sequential, structured query language query. This in these brackets here to select star from the customers. Do it one at a time, and then we're going to fetch one of a row, and then print, and then close. So the sort of open, close, is sort of start and end of the action, and this is just a setup procedure here where we're defining what are our credentials, and just import at the top, and then we're going to print it. Cool. So I feel like I can do this without a hint, but totally if you want to go to getting a hint, that's completely fine. But yeah, we thought so. Procedure here where we're defining what are our credentials. I feel like I can do this without a hint. So host, again, local host is going to be running on our computer, or is already running on our computer. Good. So port, we know the port we're running this on is 5432. We know the DB name, database name is demo. We know the user is app. Password is app. We know the port we're running this on is 5432. And we can actually, it might even be a good idea. I do understand what should go here, but it could be a good idea to get a hint. And we can actually, cool. So connecting to databases like logging to a website, you need address, port, database name, username, password. So here are the connection details from the command before. If that helps, that's good. So yeah, we want to think about what's going to go here. Look to display customer data. We're going to be printing something, and that is a row of data there. So cool, and a row is defined just there, just above it. That's good. So we can see it says add this code to your notebook. So we'll copy this code. Come back here. Plus code button. Paste that in. Very good. Nice. So paste the code into the new cell. Replace the placeholder variables with actual variables shown in the code breakdown. So we'll save the notebook. Control S on Windows, Command S on Mac. Perfect, your notebook now tells a clear story of setting up your database connection to querying actual customer data. This is a computable document. So code you can run and report, you can read. Oh, good. So now we're going to set up a Python environment for Jupyter. So we're going to open a terminal, and run this command to check where we are. This is really useful if you have this path hidden, but I don't. But you can see where you're actually working at the moment. Cool. If not in the MCP data series folder, you can just use the ask feature here to help you to screen to go. This is really useful if you have this path hidden, but I don't. But see if you're not working in the MCP data series folder, you can just use the ask feature here to help. If not in the MCP data series folder, you can just use the ask feature here to help. Yeah, so if you have any problems with not being in the right place after running, understanding that from running PWD, that's all good. You can chat away with the ask feature here. Super, super useful. So we're going to run this command on the terminal. UV add Jupyter Lab pandas, psycopg, the binary instance of that, Matplotlib, alongside. So we'll copy that, paste it in the terminal, and we can go ahead and install some packages. Cool. Install, nice and quick. So we're going to run this command on the binary instance of that, UV add Jupyter Lab pandas, psycopg, the binary instance of that. Cool. So you can see it installed correctly. That's good. One of these packages, Jupyter Lab, is a web-based interface for creating and editing notebooks. So that's what we'll interface with on the web. Pandas is a Python data analysis library. Contains tools to load, clean, filter, group, summarize, and visualize data in Python. We use this in the secret mission. psycopg is a PostgreSQL database driver. Matplotlib is Python's plotting library for creating charts and visualizations. If you're on Mac OS, you might run into what may look like an error saying no match is found. The command still works. It's normal. It's just the shell without square brackets. So now we're going to launch Jupyter Lab server that we just installed. So I'm on Windows, so I'm going to select this tab. Yeah. It's going to take a second to start up. Should be all good. So what does this command do? This command uses UV to run Jupyter Lab. That's just the configurations. So UV run Jupyter Lab starts the Jupyter Lab. So you go, starting up now. Starts Jupyter Lab application using UV package manager. The notebook directory uses present working directory PWD to open it up in your current folder. Sets Jupyter Lab to be accessible on a port. See there, it's opened up. That turns off security check, which can cause issues. And then that removes the need for a password. We're just setting this up locally. Deal. So we can see here, run this, we should see startup that we have. It's good, and we should also actually see the browser open. We did. Just do that. So in this case, we saw it open immediately. You might see it not open. Just go to it, see the default page like this. So in the left sidebar, if it didn't open up automatically, we can select the notebook, which is open. See, this is the same thing we had written earlier. This file over here. It's really cool. So now we're actually going to go and run the notebook. So now let's execute each cell and see your computable document come to life. first cell should already be selected. Your markdown cell with custom data exploration, click the run button in the toolbar or press shift enter. So click that and nothing really happened. It ran, but it's a markdown file. It's just there for explaining, documenting what's going on here. There's not a direct output from it, so that's all good. Cool. So didn't produce any output, it's fine. When you run a markdown cell, it just renders the formatted text, no output appears below the cursor. Automatically moves in Excel, this is normal. Cool. Okay, so now we're going to run the database driver. That's the psycopg. Cool, that's all good. So it looks red, but it's still working perfectly fine. Okay, still package. This can take a bit of time. Then you should see output indicating it has been installed correctly. So if there's any issues there, can look into UV. That's a common thing. Or restarting the Jupyter server. Then you should see output can take a bit of time. Has been installed correctly. So if there's any issues there, you should see UV. Cool. So we'll click it one more time. Installed correctly. Or restarting. Issues there. UV. That's a common thing. Cool. There you go. Did take a second to see the output there, but it did come through. So if that didn't pop up, then you'll get an error. So going to one of these ask in the community, great idea. So you can ask prompt as well to the ask feature here. Great idea too. If that didn't pop up, see the output there, then through. Cool. So excellent. Your computable document is working. So we've got context, which is a markdown file, explain what we were doing. We've got code, installing, preparing the environment. We've got a query as well, so that's pulling the real data from our database and actually querying it, asking what's going on there. We went into what that's doing, fetching a row, printing it, and then results showing what we found. That's like what the printing bit here, which causes us to the output of the row as we print it. This is the power of notebooks, mixing explanation, code, and results. Good. So upload a screenshot of the notebook with the 3 cells. And then results showing what we found. This is the power of notebooks, mixing explanation, code, and results. Good. So upload a screenshot of the power of notebook with mixing explanation, code, and results. Good. So upload a screenshot of the notebook with the 3 cells. Cool, so upload a screenshot of your notebook with 3 cells. Just add that there. What were the 3 cells you created in your notebook? My first cell is markdown that explains what the future content of the Jupyter book contains. What were the 3 cells? Second cell installs the package manager. Second cell installs the third cell queries the package manager. Second cell PostgreSQL database. The package manager. This makes it computable because we are both writing code. So what were the 3 cells you created in your notebook? My first cell is markdown that explains the first cell. Contains markdown that explains what the future content of the Jupyter Notebook would contain. Second cell installs package manager. Third cell queries the PostgreSQL database. This installs a database manager. Sorry, database manager. Third cell queries the PostgreSQL database. This makes it a computable document because we are both writing code and explanations. Cool. Third cell queries the PostgreSQL database. Also click our view work here to see what we're doing. Third cell queries. So cool. Yeah, let's see this. You can see this live. We'll touch on this more at the end. But it's just so. Cool. Also click our view work here to see. Third cell queries. So cool. Yeah, let's see this. Awesome. Step 3. Visualize insights that numbers can't show. You've got customers' data as text, which is rows and columns in the database. Here's the thing, patterns hide in numbers. A list of countries and counts doesn't immediately show you the distribution, outliers, or trends. That's where visualizations come in. This is why notebooks are computable documents. Some information is visual and interactive, charts, maps, plots. You can't get their customers' base is evenly distributed globally. Korea leads by much just from raw query results. You need to see it, which is very true. So let's use Jupyter Notebook to create visualization using Matplotlib through natural language, turning these numbers into insights you can actually see.
That's why we created our titanium.
So you can ask feature here as well about what are data visualizations and why are they important.
For the rest of your life.
So in the step, you're going to use cursor to add new cells for visualization to your notebook. Run the new visualization cells using Jupyter MCP. So you can ask feature here as well. Cool. So here's some information about visualization. Use cursor to add new cells for visualization to your notebook. So in the step, you're going to use visualization cells. Use cursor to add new cells. So what are we doing in the step? I'm using cursor to create new Jupyter. So what are we doing in the step? Book cells. I'm using cursor to interpreting data from I'm using cursor to new PostgreSQL database. New Jupyter cursor data cells. Create Jupyter Notebook cells for interpreting data from my PostgreSQL database. Matplotlib helps me visualize visualize maps, charts, etc. Helps me visualize, etc. So what are we doing in this step? In this step, I'm using cursor to create new Jupyter Notebooks, new Jupyter Notebook cells for interpreting data from my PostgreSQL database using MCPs. Matplotlib creates, helps me create maps, charts, etc. from my data, for my data. In this step, I'm using cursor to create new Jupyter Notebooks for interpreting data from my PostgreSQL database using MCPs. Matplotlib creates data, helps me create maps, chart database, etc. from my MCPs for my data. So this part we use cursor chat to create visualizations. Matplotlib. Now for the magic, let's use cursor's chat to create data visualizations through the Jupyter MCP. So first we're going to open the chat and then send this prompt. Open. So now part of the magic, let's use cursor chat to create data visualizations through the Jupyter MCP. So we'll add that prompt to the chat. It's just a warning for an old cursor I'm using. It's totally fine. Cursor will use the Jupyter MCP To create cells, you'll see cursor response showing it's interacting with Jupyter MCP. Cool. Cursor will use the Jupyter MCP to create cells. You'll see cursor response showing it's interacting. See it doing that here. Use the Jupyter MCP to create cells. You'll see cursor response showing it's interacting with the Jupyter MCP. So it's called setup notebook. Makes sense. Let's modify specific cells here. Cool. Wow, Cursor just created 2 new cells, one to install Matplotlib, another with visualization code. No manual typing required. How good. Now let's have Cursor run those cells for you. Let's modify specific cells here. Wow, Cursor just created 2 new cells, one to install Matplotlib, another with visualization code. No manual typing required. Wow, Cursor just created 2 new cells. Now let's have to run cells. Yeah. Now let's have Cursor run those cells for you. Yeah. Cool. So both cells being executed correctly. So we'll pop back onto our lab, refresh page, scroll down, see stores Matplotlib here, and then we can see. So a little bit. Might cut it off, but that is a exploration full screen is just for now. That's it. So we can see here the customers from our database plotted by countries. So that's really cool. You can see Korea is leading. It's relatively consistent across. Korea is definitely leading. You can see here the customers from our database. You can see it plotted. See here, the countries, customers, really cool. Korea is leading, plotted relatively. So Cursor here, executing notebook code, makes plenty of sense. Relatively consistent across. So now check the visualization, switch to the Jupyter Lab browser tab, refresh the page, and you should see the chart. So the chart didn't display, it didn't work. Go into here. Go talk to the community, create Discord server, or ask for help with visualization code to the ask prompt, or to the ask chat, sorry, space over here. Super useful, but because the chart displayed for us, we can continue down this route. Super cool. So now you can see the insights that we spoke about. Look at the chart, the distribution is surprisingly balanced. Korea leads, but the top 10 countries are all within a similar range. This tells you that your customer base is geographically diverse, not concentrated in one region. This is why visualizations are essential for computable documents. They reveal insights that numbers alone cannot convey. You can add a markdown cell for our findings. Let's document what the visualization revealed in Cursor. Click the plus markdown button to add a new markdown cell to below the chart. So then come back over here. The chart is also click plus markdown. We can send it in this. This is the essence of computable documents, mixing code, visuals, and insights into a single narrative. Super useful. Now we know as a result of running this plot, our thoughts and feelings, we can come back to this, or someone else can come to this shortly. And yeah, they'll be able to tell pretty easily what's how we interpret the results. So now we're going to go and enhance our visualization using Cursor. So this is an add-on here, if we wanted to. And in the real world, this could be quite useful. So let's try and improve the plots. Make it look more professional. So again, you're going to send this prompt off to Cursor's chat, and it's going to go through and call a bunch of stuff, so querying notebooks, probably executing notebook code as well. and then we should be able to see an updated view. Send this prompt off to cursor's chat, and it's going to go through and get all of the Jupyter Notebooks. Send this prompt off to cursor's chat, and it's going to go through and all of the stuff, so you should be able to see an updated view notebook code as well. And then we should be able to see an updated view. Cool. And refresh the Jupyter Lab here. Look. Wow. Super professional looking. You can see the color gradient from the highest number of people down to the lowest. It's really clear. You can see the results we understand from here. So anyone reading this that's fresh and hadn't seen this before can actually go and read that. Color gradient from the highest number of people down to the lowest. You can see the clear color gradient. You can see the results we understand. Highest number of people down to the lowest. So anyone reading this that's fresh and so we just checked the enhanced visualization we looked at. Created just then, sorry. So we'll switch to our Jupyter Lab browser tab, refresh the page. If we did, should see some chart professional styling, which is what we do. Looks a little different, but that's the cursor to choose how it's going to display it, and it did it slightly differently, so that's all good. Some other stuff you can experiment with in cursor chat. You try adding a cell which shows up, shows the top 5 products by price. So encourage it to run it. The Jupyter cell, so you can see that, create a pie chart, showing customer distribution instead of a bar chart. Jupyter cell, query, orders, data, and show total sales by month. Query. The more you experiment, the more you'll see how MCPs accelerate your data exploration workflow. So the MCP advantage, if it's clear already, Jupyter Notebooks are built for iterative exploration, test a query, see results, refine, repeat. MCP supercharges this workflow by letting you create queries, run cells, and iterate through conversations. You stay focused on exploring your data instead of managing the notebook interface. Photo of our full screen screenshot. Photo to this validation. Visualization of the customers over tree. How did you add visualizations to your notebook? I use Cursor to add visualization cells to my notebook. As the bar chart, which the bar chart shows the top 10 countries. Products. This helped me see that Korea was the highest purchased most products. This helped me see countries that e-commerce base. Korea, e-commerce is highest store. That Korea was the highest product purchased. Cool. So how did you add visualization to your notebook? I use Cursor to add visualization to my notebook, such as the bar chart. The bar chart shows the top 10 countries that purchase products. This helped me see that Korea purchased the most products. Cool. So how did you add visualization to your notebook? I use Cursor to add from our e-commerce store. Cool. All right. Secret mission time. So now we're going to transform our data into production. So ready to level up? this section is for those who want to take their skills further. You'll transform your Jupyter exploration into a production-ready DBT model that runs on a schedule and can be queried by your entire team. So we can see here, we start off with exploration. With exploration inside of Jupyter, trying to find something we want to interpret. It's very common to not know exactly what sort of visualization you're actually looking for in the end, or even what sort of data you'll be looking into. And by the start, initially you won't. But yeah, that's a really good space to explore in Jupyter, like we've been doing so far. The next thing is extracting the query, which is what we're going to go into with these top three, the yellow, pink, and green. Extract query, DBT model, and add tests. That's what we're going to be going to in the second mission. So we're going to extract the query, then we create this as a DBT model, add tests, and then give access to the team. The next thing is extracting the query. Cool. Extract the query, create this DBT model, add tests, and then mission. So your Jupyter Notebook is a computable document, perfect for exploration and sharing findings. But now you've found something valuable, customer distribution analysis that your team needs regularly. So that would be the this plot here, all the information that you can output from this plot. In this secret mission, get ready to convert your latest query into a DBT model using the DBT MCP. Add data quality tests to ensure reliability, and materialize the model and query it from Jupyter. In this secret mission, get ready to convert your latest query into a DBT model using the DBT. So what are you doing in the secret mission? I'm going to turn my notebook query into a DBT model. This means materialize the model and query it from Jupyter. Converting. What are you doing in the secret mission? I'm going to turn my notebook query into a DBT. Converting the. So what are you doing in the secret mission? I'm going to turn my notebook query into a DBT model. Python code into a query. And setting this up. DBT. To be converting Python code to SQL query, setting Python code to we can also talk about the quality, the data test as well here to a query, adding data quality tests, and then I'm going to turn my notebook query into a DBT model. This means converting the Python code into a query, adding data quality tests, setting this up with DBT, and setting this up with DBT, data build tool, to be ran in SQL. This means converting the Python code into a query, as a query, into a DBT model. This means converting the Python code into a query and setting this up with DBT. Cool. So the real world workflow here is exploring in Jupyter. Did you find value? If you did, then productionize with DBT. Validate, check it actually works, verify with tests. If it failed, go back to step 2, which is productionize with DBT, adding or changing code, updating test cases. If it passes, we can scale to the team and really answer the question effectively that we've been set out. We set out to ask. So set out to answer, we were asked. And then we can go back to exploring if we have any new questions from the team. Or just yourself, you don't have to work in a big team to use Jupyter. Thank you, Natasha. That's my favorite MCP expert. Thank you. So you've already explored in Jupyter by hand. Jupyter by hand in step 1. Now you'll productionize it. Productionize that work. We're going to turn your query from step 3 into a DBT model, add tests, and make it available to your team. This is how data teams scale from personal analysis to production data products. Check your prerequisites. I have DBT configured. I don't. 2 options here. Go to cursor. Go to settings. And we can see here that I don't have DBT configured. So I'll select need to set up DBT. This takes about 15 minutes. Cool. In. So I've got a new terminal. Copy this link, make sure we're in the right spot again. We can run this command to initialize DBT in this UV environment. Should take a second. And ask us to give it a name as well. Shouldn't take too long. Copy this link, run this command to initialize DBT in this UV environment. We can run this command to pull this up here so we don't have a lot of DBT in this UV environment. So it's asked us to enter a name. So we're going to type the name demo. That's what we state here. Overwrite what I have currently. Enter a number. So which database? Select Postgres with 1. Do the default port. You can type it in or just press enter. Sorry, localhost is the next thing. Jump 1. 2 is localhost. Is the name. We can enter 5432.4. Just press enter. Select that in default. We select the username here. And and the password is @ the DB name as demo. Schema we're going to call @ select 1 thread. So we should see a demo file appear here. We can. That's very good. So now we're going to go and actually add DBT MCP to cursor. So we go to settings, MCP, add MCP server. We can see the mcp.json file. Select Windows here for adding this. I'm on a Windows computer. So we'll open run this command here. Copy the output, then add it to your mcp.json. Replace MCP, your MCP series path with the path from the command above. So we'll check that out now. Your username with your Windows username, it's in the present working directory output after users, so it's the OKH20 thing here. So now we're going to copy this, slot it in after Jupyter, comma, paste that in, save file. Again, because we're adding a new MCP server to our cursor configuration. Okay, I think your audio is echoing, repeating itself, by the way. Alright, I've turned off the user on there. Apologies if that was an issue earlier. So we will quit cursor because we need to add a new MCP. And then reopen it. To make sure the MCP is actually running. Awesome. Just wait for these to show up green or not. So document your secret mission is the next stage. Before we start building, let's add documentation to your notebook explaining what you're going to do, you're about to do. So we'll go back, should be ready in a second. We'll go back to the demo.ipynb, add another markdown section after it. If we jump back to the previous validation, we can actually copy it from here, because this is what we actually need to be doing here. That's what we're doing. This documents why you're creating a DBT model for future you and your team. Well, thank you, definitely. So now we're going to go ahead and create the DBT model. So your demo.ipynb notebook has a customer country analysis query. Let's turn that into a production DBT model. What is a DBT model? A DBT model is an SQL file that transforms raw data into useful tables instead of running ad hoc queries. In Jupyter, you define the transformation once in DBT and it runs on schedule to keep data fresh. Think of it as your Jupyter notebook. It's a scratchpad exploring data and a DBT model's production ready version, tested, documented, and ready for the whole team to use. Cool, so let's send this prompt off. So the prompt says, using the DBT MCP, create a new DBT model at models in that model file directory we just created here. Include countries, not just the top 10. Make sure the model materializes in the app schema. Audio is all good now. Good, thank you. Cool, so Cursor will use the DBT MCP to create the model file. Here, so it created this models. Yeah, it created this, which is good. What are we asking for in this prompt? So the models, the SQL file, the structured query language file you need to create, is telling it where to create the file, app.customers, the source table you're querying from, the source table you're querying from. This is the raw customer data from the database, PostgreSQL database. We're going to include all countries, not just the top 10. So don't limit the results materialize in the app schema. So just saying do this in the app schema or database or data lives. So now we're going to inspect the generated model. We have this open here, SQL file. It's inside of demo/models. Open the file and read the SQL. Just wrote. Cool. So this is interesting. Looking at the difference between the Python code and the SQL model we derived from effectively. So let's compare what you wrote in step 3 versus what the DBT generates. So your Jupyter notebook in step 3 looked like this. You've got an import, you've got a connection or set of connection details, so where you're connecting to effectively, and then a start and a stop where you actually do the query and then define what a row is and then show or print the row. So notice all the Python code needed to run simple query, import statements, manual connection, SQL wrapper, converting results to a data frame. The DBT model, just a clean run with SQL with the DBT configuration, So config at the top, saying what table, what schema, no imports, no connection strings, no like passwords or anything need to be exchanged. Cool. Why is this better for production? The DBT model is cleaner, testable, versionable, and can run on a schedule. The notebook was perfect for exploration. DBT is perfect for production. In cursor chat, send this prompt. So we're just going to add some tests to the schema.yaml file. Awesome explanation. Introduction. So Cursor is going to update the schema.yaml file, which is where the tests are stored. I'm going to go and add some there so we can actually test the quality of our database with this DBT model we're creating. So it's just verifying the updated tests pass correctly. So created a schema.yaml file. It's all good. Do that here. Checks country is not null. Custom account is greater than 0. Country values are unique. Cool. So we use this prompt to actually run the tests. That are just built. We're gonna check if the results line up and make sense. Well, the data quality is good, which if you remember is a key part of the diagram. We scroll up here, but ways. So this is the step here, making sure it doesn't fail effectively, and if it passes, we can move on. That's great. Cool, so it just compiled and it's just showing the tests now. Ran and compiled the tests. We'll get the results in a second. Let's see if yeah, that's okay, that's fine. It's all good. The secret mission is so lit, Matt. Thank you very much. Totally. It's awesome. It's great. It's a really good, like, full circle moment being able to go from, like, designing to actually executing and using your initial explorations out of Jupyter. So, yeah, super cool. Cool. There you go. So, the model execution, it checked, went through, it said all tests have passed, so that's great. But how do we actually know it worked? Cursor said the model ran successfully, but how do we know the table already exists in the database? Let's verify it ourselves using PostgreSQL command line tool. Data engineers will check their work, will connect directly to the database and inspect what's really there. So make sure you run the model first, really important for this next bit. You can also use DBT to run if that didn't work. Cool. So open a terminal, send the following prompt. So what we just did was connect to the database. So docker exec runs a command inside your container, dash it makes its directives. You can type commands. pg local specifies the container name, created at the start, and PSQL, you app the demo opens the PostgreSQL client as user app and database demo, and the demo prompt you see means you're connected and ready to do your first command. Once you're connected, list all tables in the app schema. So we run that DT app. What does the DT part mean? DT is a PostgreSQL command that shows all tables. The app gets the app schema where the DBT model lives. So you can see here, it's a bit bigger. We can see the list of tables. So for customers, order items, orders, and products. And for more, there are tables, so we know they're there. It's great. This table will be in the 4 below. And we can query it directly with this SQL command. Okay. Doesn't exist apparently. Customer, country. Okay, cool. Want to do some live debugging? That's totally fine. Use cursor for this. I wonder if this is to do with the error that it came across that may renamed something. So I'll just send it the terminal. Maybe it can explain if it changed anything. Docker is still running. Yeah. Okay, it looks like it created an @_app, not just app. That's completely fine. Let it fix that. Okay, let's have a look, see if we can create that again. There you go. So it created it in the @_app schema tag. So it's unfortunate, but that's all good. Managed to fix it. I removed the extra schema tag there, and now it's clearly showing that this has actually worked. You can see that the country's not just 10. Well, it shouldn't be limited to 10. There is 10 here. but that's just the number of countries we actually have total. So yeah, we can see that lines up well with the this plot here. So that's great. So what is query doing? Select gets all the columns from the table from at customer country summary queries your DBT model. So that there was an issue with that. We were querying, or we were going from at customer country summary. So one extra layer. We can fix that by removing the extra at tag. Says here uses it automatically. We were or cursor had written the code to specify it anyway. So we were going 2 layers there. So order by sorts by highest customer count countries, and then shows the top 5. So here, 1, 2, 3, 4, 5. So you're seeing a pre-aggregated production data. You're seeing your pre-aggregated production data. So we can now quit. We understand it's there. That's great. Leave the database. So yeah, it's the \q. So we'll upload a screenshot of our query results here. Cool. Let's save that. It downloads. Cool. How did you manually verify your DBT model exists in the database? So I verified my model by connecting to Postgres using, go back to this command here. Commands I ran were, leave that to there. By using Docker exec remote exec. The commands I ran were, it doesn't make sense to put this. Yeah, it's the commands we ran inside of the terminal once we were there. So first, we listed all the tables that were there. List all tables. Then query to get the top 5 countries. In terms of cool. So how did you manually verify your DBT model exists in the database? I verified my DBT model by connecting to the PostgreSQL using Docker remote exec. The command is listed there. The commands I ran were DBT app to see the listable tables. Then we used the query to get the top 5 countries in terms of customer count. Cool. So what changed between notebook and production? Your notebook query runs every time you execute the cell, scans thousands of raw rows, aggregates on the fly, slow for large data sets. Only you get to use it, and there's no data quality checks. So the DBT model we just created runs once or on a schedule. Set that up. Results in results stored in a separate table and pre-aggregated. So queries are instant, effectively stored in memory. Memory is the SQL file. Anyone with database access can use it. That has built-in database quality tests. So checking if they're null or they're unique or a certain value, or greater than a certain value. Sorry. It's common. So why are we using notebooks at all? Notebooks for exploration and discovery, testing ideas, finding patterns, documenting your thinking. Once you've discovered something valuable, that's when you productionize it with DBT. You need both notebooks to figure out what to build and DBT to figure out or to build it for production. And why is the DBT model more shareable? It's not about sharing files, it's about accessing data. Your notebook's query only works when someone runs your notebook. The DBT model creates a table, real table in the database that anyone with database access can query from by tools, dashboards, or their own code. No notebooks required. Cool. So mission complete, having issues, 2 tabs here. So everything seems to have worked. We had that little hiccup with an extra scheme of app was added. That's okay. If you are having any, so we're not having any issues now, but if you are, there's some troubleshooting tips here. You can use the ask prompt here to access the ask feature to go and query, see if it can help you out. It's genuinely a very, very good tool. Or definitely head to the Network community, the Discord. There is great as well. We're going to go to the mission complete section. Scroll next there. Cool. So one last thing here, I think. What's the difference between notebook exploration and production models? The difference between my notebook and the DBT model is my notebook was built to show my thinking and understanding, computable documentation, whereas my DBT model was built to share my team database access to understand the same trends built on my Jupyter Notebook to share with anyone in my team that has database access to understand the same specific trends. So what's the difference between notebook exploration and production models? The difference between my notebook and the DBT model is my notebook was built to show thinking and understanding, computable documentation, whereas my DBT model was built on my Jupyter Notebook to access, to share with anyone in my team that has database access to understand specific trends. Cool. Your response helped me learn about the difference. I'm so glad. Okay, secret mission. Sorry, before you go, we'll finish the secret mission. Now we're in the cleaning up resources stage. So we can, it's a little smaller. I think this is actually stopped up here, but if it's not, you get back to here and do Control-C to actually close it. If you're prompted why, press that when you do it to select it and close it. So you can close your Jupyter browser tab, which you can see is timed out because the Jupyter server is closed. If you want to keep PostgreSQL running, that's completely fine, but it's it'll take up resources on your computer. It's not going to cost anything. I'm going to close mine, pause it. You could run this command as well. You can prompt cursor to any of these, or you can uninstall as well. That's a wrap. Secret mission complete. So we did it. We built an interactive Jupyter notebook that connects to your database and allows you to create data visualizations. So what you learned, how to create and run Jupyter notebooks, connecting Python applications to PostgreSQL, querying databases with SQL from Python, creating database visualizations with Matplotlib, that's those charts, best practices for presenting data visually, that's organizing text and visualizations in a way which someone new or new later on can read it, using MCP, model context protocol, to manage notebooks through natural language. That was just the entire thing, talking to it in cursor. Cool. So what were the key tools and concepts you learned in this project? The key tools I used were MCPs, Jupyter Notebooks, like cells, code cells. We need to keep this down to the concepts. MCPs, Jupyter Notebooks. Docker, the main concepts I learned were code cells, let's say markdown cells. DBT model tests, best practices when laying out computable documents, where to put text. So I was able to ask questions myself. I had myself, where should I put text? Where and when do I put visualizations? When? Cool. So back to the end. How long does this project take me? The live stream is about 2 hours, so the project took me 20 minutes. Most challenging part was, say, getting the DBT, maybe the notebook to query my database. I did this project because to learn about how and why I should use notebooks to go from idea to real query, real world use, e.g. in the data engineering team. So what were the key tools and concepts you learned in this project? Key tools I used were MCPs, Jupyter Notebook, notebooks, I guess, notebooks from Jupyter Notebooks, PostgreSQL and Docker. The main concepts I learned were code cells, markdown cells, DBT model tests, and best practices when laying out documents. So that could be when or where to put text, or when or where do I put visualizations to make it really clear to the user what's going on there. I will share my documentation chat. I can't actually put stuff directly in this chat, but I will, yeah, I'll send this to the Discord. How long did this project take you to complete? It took 120 minutes. The most challenging part was getting Jupyter Notebook to query my database. Why did you do this project today? Did you meet your goals? I did this project because I wanted to learn about how and why I should use Jupyter Notebooks to go from idea to real world use, e.g. in a data engineering team. Cool. So we can quiz ourselves now. What is the role of MCP, Managed Compute Provider, in Cursor? So an MCP is to replace the need, I'll just go through the option, to replace the need for Docker and PostgreSQL, to manage operating system computer, to directly compile Python code, to provide a way to connect Cursor with external services. Sounds right to me. What connection details are required to connect to a PostgreSQL database from a Jupyter Notebook? Browser, type and version, on the database name and user, host, port, database name, user and password, operating system and IP address. C. Why are data visualizations important in a Jupyter Notebook? They automatically correct errors in the dataset. They reduce the size of the notebook file. They reveal patterns and insights that are not immediately apparent from raw data. They are required for the code to run correctly. I would say they reveal patterns and insights. What is the primary purpose of a Jupyter Notebook? To manage Docker containers, to design web pages using HTML and CSS, to solely execute Python code in the terminal, to create computable documents that combine code results and explanations. It's right to me. Question. What is the correct file extension for Jupyter Notebook? Not Markdown, not Python, not JSON, definitely IPyDB. Cool. So we're finished. That's great. Awesome. We can have a quick look at the documentation. Wow, that looks awesome. So we can see the title here, my name, and then the plot we actually created. Talk about what we're doing in this project, how long the project took us, connecting with Cursor, showing the results there. What is my first notebook? 3 cells here, start, Jupyter Notebook, ran this. Creating data visualizations, cool, verifying my work, sure this is actually there, and then the results, what we thought, notebook first production, live URL, put it in Discord now. Cool. Let's have a look at the LinkedIn. I have to switch browsers. Cool, so you can see here we can share on LinkedIn. This will be the live project link we have over here. It explains a little bit about what the project is and yeah, how we're going to set it up. Totally share on Instagram, TikTok, anything like that. Download a PDF as well. Yeah, well, I think that's been a great success. I really enjoyed that project. The documentation is so sick, and that's awesome. Such a strong header here with this image, so impressive. So definitely recommend anyone that's thinking of checking this out to go ahead and check it out. Super cool. Anyway, I think I might head off if there's no more questions. Cool. All right. See you guys later.